Hi, my name is Ed Thompson. I'm a CTO of Matillion. Today I'm going to take you through what's new in version 1.32 of Matillion ETL. So let's take a look. So as usual, let's take a start by looking at all the new connectors in this edition of Matillion. First, we have the SendGrid query. SendGrid is a popular email delivery platform, and you can connect to your SendGrid account with a username and password. We have a variety of sources which the SendGrid API exposes, including lists, marketing campaigns, segments, etc. The Elasticsearch query component connects to the popular Elasticsearch service. This allows you to perform searches and queries directly against Elasticsearch. And a lot of users we're finding use Elasticsearch as a data storage engine as well as the search engine. Here you can connect to your Elasticsearch server, get connected to whatever data sources. We've just got one data source in here, but a lot of other sources are available inside of Elasticsearch, and they'll be shown in this component. Magento is a very popular e-commerce system, both on-prem and in the cloud. Again, you can connect to an on-prem or cloud version of Magento with a username and password. And then Magento has a quite extensive API, so there are many data sets that you can pull from the e-commerce system into Matillion ETL. Zuora is a popular subscription software payment platform. Also has an extensive set of objects that are available from the Zuora API. The important thing with Zuora is, in advanced mode, queries are written in Zuora's own SQL-like expression language called ZOQL. Users familiar with Zuora will probably be fairly familiar with writing reports in ZOQL. The final component is the Gmail query component that connects to Google's popular email service, as well as G Suite for Business. Users can connect to an inbox and pull all of the email information from that inbox, including the folder structure, sent items, etc. The Gmail component is very similar in design and scope to the email component, which is designed to connect to a generic IMAP system. Next, I'd like to take a look at some of the new orchestration components that we brought in to Matillion ETL. In the last edition, version 1.3.1 of Matillion ETL, we introduced the concept of grid variables. Grid variables are two-dimensional variables that allow you to specify lists or grids anywhere where a component would normally need a list or a grid. So, if I use this RDS query component by way of example, we see that, for an example, the way we specify a sort key, we choose a list of columns from this list. This could be used as a grid variable instead. Similarly, if we look at the create table component, the metadata is specified as a grid variable. So the columns in the table are specified in rows with their data type, size, decimal places, etc. Grid variables introduced a way to replace these pieces of static metadata with variables. This meant you could build Matillion ETL jobs that were entirely dynamic, where all the elements were specified by variables. What I've tried to do here is to build an example where grid variables may be useful in a real-world scenario. Here we have two input tables in a typical third normal form ERP system, where you have a headers and lines relationship. What I'm trying to achieve with this job is to denormalize these two tables into one flat table. But I want to build the job in such a way that it's fully dynamic. This means if new columns were added to the lines, then they would automatically find their way into the output table. Let's go through how this job works by way of an explanation. We have a starting point, and then we load our two tables using the RDS query component, the headers and the lines. Once these tables are loaded into Redshift, we use a new component called the table metadata to grid. This does exactly what you'd expect. Takes the table metadata from a given table and adds it to a grid. To set this component up, we specify the table name that we'd like to use to get the metadata from. We specify a grid variable, which we created earlier, and we specify a mapping. In the mapping, what we see down the left-hand side are the field names in my grid variable. And what we see in the drop-down boxes are the available field names from the component: name, type, database, size, precision, encoding. Everything you need to extract the metadata into your grid variable. We do the same thing for the header and the line information, and we bring the two parallel flows together. There are some duplicate columns that are in both the header and the line, so we need to deduplicate them. To do this, we use a new component called remove from grid. In this particular configuration, we take our header schema and we remove it from our line schema. What this component will do when set up like this is remove any duplicate columns that are in both. So you only get one of that given column. In this example, we do it using the name column from our grid variable. In order to create our output table, we're going to need to take the data from the headers and the data from the lines. So to do that, we use the append to grid, which does the opposite of the remove from grid variable. In append to grid, we're starting a new variable, which will be our order schema. This will be our output table, and in this example, we have one append component that adds our order header schema to our order schema, and we have another one that adds our order line schema to our order schema. So what we end up with is an order schema variable that contains all the column headers and all the column lines in one variable. We can pass this variable into our create table component. This is specified here in the table metadata, where we're using our order schema as a grid variable, and we have our name, size, precision, and encoding set. When this particular job gets run, the data will be loaded, the metadata extracted, and then deduplicated and appended to a new variable which will be used to create our output table. You can see I've got a couple of Python components here, and these just exist to print out our grid variable. So when we run the job, I can see exactly what's going on with the grid variables that I'm manipulating. So they're debug, really. Now we could end there, but I wanted to take this one step further and actually transform the data from the staging tables for the order headers in order lines into my final target table. So let's take a look at that. It's a very simple transformation that just joins the order headers and the order line tables together to output the orders. However, if we look into the configuration, you'll see once again that we're using grid variables that we've passed into the component. First of all, the column names that I want to specify for my header and lines are just taken from the name grid column of the header schema and the line schema that we extracted earlier. Those are then joined in this SQL component, and then finally, in order to get our output component to work, we need to map our output table order schema, and that's simply mapping the input column to the output column because we're not renaming any columns at this point, both of which are called name. Let's run the whole thing and see if it works. I open up my task data, we'll see that all the stages have run, and we can see that we've printed our variables. This was my header after I deduplicated it, and these are just the header columns listed out. And then this is the output table. So these are all the columns that are going to be created in my output table. And then, of course, the data is transformed and loaded into my output table. Finally, I'd just like to show you the only component we didn't use in this job, which is the query result to grid. In the same way that the table metadata to grid component allows you to get the metadata into a variable, the query result to grid component allows you to extract the actual data from a query into a grid variable. To use this, you specify the table name and the columns that you'd like to query, or in advanced mode, you can write your own SQL query. How you'd like it ordered and sorted and limited, and finally the grid variable and the mapping you'd like to specify. Next, I'd like to talk about another new feature of Matillion ETL called permissions. This is an enterprise feature and is therefore available in the large and extra large instance types. Permissions essentially allows you to authorize what individuals can do inside projects in Matillion easier. The permission system is very fine-grained and it allows you to drill down into any one of the 150 or so different commands that make up the Matillion ETL user interface. Let's take a quick look at what's new in the permission system. First of all, in the admin menu, you see two new menu entries, Manage Permissions and Manage Groups. Let's take a look at Manage Permissions first. Manage Permissions is where you set up permission groups. We've set up 5 permission groups to get you started. These are Reader, a read-only user who can't modify a project. Reader with comments can't modify a project but can add comments and notes to an individual job. A runner also can't modify a project, but they are allowed to execute jobs, run jobs, sample data, etc. A scheduler is a user who can execute and schedule jobs and change some of the related config, such as OAuth settings. And finally, a writer. A writer is similar to a normal user of Matillion ETL that you've been familiar with up till now, but they can create ETL jobs with certain protections built in. For example, they can't delete projects or versions. If we drill into one of these permission groups, we can see how they're set up. Inside the permission group, I can see my base user permissions folder and my default state is forbidden. The expected state column tells us the inherited state. If I drill into the permissions, we can see at this level most states are left unspecified, so the inherited state applies. Hopefully the names of the permissions are self-explanatory to users who have been using the product. For example, if I drill into the project here, we can see at each level we have a read and a write folder. This is for reading and writing project permissions. And then the same within the environment. And if I move down into a schedule or a version, we can see I have write permissions, or if I move into a job, we have read, write, and execute permissions. If I move from a job down into a component, we also have write and execute permissions. We can set these right down at the orchestration or the transformation level. If you drill right down, you can see the individual commands that make up the Matillion ETL user interface, such as handling connecting orchestration components, creating orchestration components, deleting them, the status, etc. You can use this interface to build up complex permission sets that meet your specific needs. Once permissions have been set up, you can manage users that use these permissions set in the group section here. You can click on membership and you can see for an individual permission set, for example, this particular user has the permission group reader with comments. If we back out of this now, we can see how this applies. If I open up a new browser and log back in, I'm now logged into the same project, but with read-only user. We can see that the project menu, the elements like manage project, delete project, import, etc. are grayed out. Similarly, if I start moving components around, I get a permission error to say that it's not possible. If I was to create a new folder, you see a permission denied error. The permission deny error will show you the permission that you don't have in order to perform that particular action. So this makes it easy to work out what permissions you need to do certain operations in the user interface. For customers that have connected Matillion ETL interface to an external LDAP server, the LDAP server groups can be mapped to permissions in Matillion ETL. So the users and groups can be managed outside of the product. Let's take a look at some of the other changes and features that have been added in this release of Matillion ETL. When setting up schedules, it's now possible to run the schedule in the state that you've created it using this Run Now button. This makes it easier to run schedules in the state specified. Many components now have a double-click action on the canvas to open up the default editor. For example, in the Python component, you normally want to edit the Python, so just double-click on the component and it takes you straight into the Python editor. An important security change in this release is that when customers are using the internal security, passwords are now hashed than when stored on disk. Also, using the external security, it's possible to use KMS to encrypt the connection password. So that's given you an overview of the new features in version 1.32 of Matillion ETL. If you want to get started, go to the Google Cloud Launcher. Otherwise, you can visit matillion.com for more information. Thank you very much.